This work presents an aerial tool towards the autonomous, cooperative coverage and inspection of a large-scale 3D infrastructure using multiple unmanned aerial vehicles. The proposed method has been evaluated with the utilization of the Ascending Technologies NEO hexacopter, and the onboard localization system is based on ultra-wideband technology. To enable autonomous inspection, the experimental setup combines multiple processes, including the coverage path planner, the ultra-wideband based state estimation, the high-level position tracking controller, as well as the post-processing of the visual data to provide 3D reconstruction. The wind turbine is located in Bureå, Sweden, and has a height of 64 meters and a blade length of 22 meters. The localization system for outdoor use is the key technology towards autonomous flying. Due to the wind turbine being a tall building, the multipath errors cannot be avoided and the GPS could not be used. In this work, the fully autonomous navigation of each platform on the designated path is enabled by the localization system that fuses ultra-wideband with inertial measurements through an error state Kalman filter. A geometric approach is developed for the inspection problem of a complex 3D infrastructure using multiple UAVs. In order to complete coverage missions in a short time, an offline, cooperative coverage path planning has been developed to generate multiple paths for each agent. Each agent covers a different path of the scene autonomously while avoiding collisions. The wind turbine is a challenging infrastructure to inspect because of high wind gusts, and the increased height tests the limits of the platform navigation and localization. The developed inspection architecture supports the simultaneous deployment of multiple agents, navigating around and collecting all the necessary data according to the operator requirements. The visual information collected from the aerial team is collaboratively processed to create the 3D model. The wind turbine as a structure is challenging for visual processing due to the lack of texture and its uniform color. In this approach, structure from motion combined with multi-view stereo algorithms have been used to provide the 3D model of a part of the structure. The presented inspection system could create a significant impact on the competitiveness and the growth of the European robotics industry, especially in the field of service robotics. With further development and additional features, this proposed tool has the potential to be an integral part of infrastructure service businesses, while all the relevant technologies have the potential to provide leading solutions in a wide set of fields and applications.